What if I told you that in 2017, something from another star system visited our solar system, and one of Harvard's top scientists believes it might have been sending us a message? Oumuamua, the first confirmed interstellar visitor, has sparked the most controversial debate in modern astronomy. When Joe Rogan sat down with physicist Avi Loeb, the conversation revealed shocking theories that challenge everything we thought we knew about our cosmic neighborhood. Today, we're diving deep into the mystery that has scientists questioning whether we've already encountered alien technology. The discovery that changed everything. October 19, 2017, marked a historic moment that most people completely missed. On that day, astronomers at the Pan-STARRS telescope in Hawaii detected something that shouldn't exist, an object moving through our solar system at impossible speeds, following a trajectory that proved it came from another star system. Named Oumuamua, meaning messenger from afar arriving first in Hawaiian, this mysterious visitor was unlike anything scientists had ever encountered. The object was traveling at 196,000 miles per hour, far too fast to be captured by our sun's gravity. Its hyperbolic trajectory confirmed what seemed impossible. We were witnessing humanity's first confirmed interstellar visitor. What made this discovery truly extraordinary wasn't just its origin but its timing. Astronomers estimate that interstellar objects like Oumuamua pass through our solar system about once per year, but they're typically too faint and fast to detect. Only recently had our telescopes become powerful enough to spot such visitors. The fact that we caught this one suggested either incredible luck or that these objects might be more common than previously thought. Within days of its discovery, Oumuamua would reveal characteristics that would divide the scientific community and spark debates that continue today. An object unlike anything we've seen. The more scientists studied Oumuamua, the stranger it became. This wasn't just another space rock. It was something that defied every category astronomers had for celestial objects. The object's shape was the first major anomaly. Based on how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was extremely elongated, roughly 10 times longer than it was wide. To put this in perspective, imagine a cigar that's 1,300 feet long but only 130 feet wide. No asteroid or comet in our solar system has ever been observed with such an extreme aspect ratio. Even more puzzling was its behavior. As Oumuamua rotated every 7.3 hours, its brightness varied by a factor of 10, the most dramatic brightness variation ever recorded for a natural space object. This suggested either an incredibly unusual shape or surface properties unlike anything in our cosmic neighborhood. The object's reddish color, similar to objects in the outer solar system, indicated it had been wandering through interstellar space for hundreds of millions of years, its surface reddened by cosmic radiation. Yet despite this ancient journey, Oumuamua showed no signs of the dust or gas emissions typical of comets when they approach the sun. The acceleration mystery that baffled scientists. Just when astronomers thought they understood Oumuamua, the object delivered its most shocking surprise. It was accelerating away from the sun in a way that gravity alone couldn't explain. This non-gravitational acceleration was subtle but unmistakable. As Oumuamua sped away from our solar system, it was moving faster than it should have been based purely on gravitational calculations. For comets, this kind of acceleration is normal. Ice vaporizing from their surface creates a rocket-like effect. But Oumuamua showed absolutely no signs of cometary activity. The acceleration was consistent and measurable, ruling out random forces or measurement errors. Something was pushing Oumuamua, but what? Traditional explanations fell short. The object was too small for solar radiation pressure to account for the observed acceleration, and it lacked the outgassing that typically propels comets. This mysterious acceleration became the smoking gun that would fuel the most controversial theory in modern astronomy. If natural explanations couldn't account for Oumuamua's behavior, what could? The answer would come from an unexpected source, Harvard's Department of Astronomy, where one physicist was willing to consider possibilities that others dismissed as impossible. The stage was set for a scientific revolution that would challenge our understanding of our place in the universe. Avi Loeb's revolutionary theory shakes science. When Harvard physicist Avi Loeb appeared on Joe Rogan's podcast, he dropped a bombshell that sent shockwaves through the scientific community. Oumuamua might be artificial technology from an alien civilization. Loeb, former chair of Harvard's astronomy department, wasn't some fringe theorist. He was a respected scientist with hundreds of published papers, who had simply followed the evidence to its logical conclusion. Just like Sherlock Holmes, I follow the evidence, trying to find the solution. The physicist's theory centered on one key insight. Oumuamua's unusual properties perfectly matched what engineers would design for an interstellar light sail. Its extreme thinness would minimize damage from interstellar dust, while its flat geometry would maximize surface area for solar radiation pressure. Exactly what would propel a light sail through space? Loeb's calculations showed that solar radiation pressure could indeed account for Oumuamua's mysterious acceleration, but only if the object was incredibly thin, like a sheet of paper tumbling through space. This wasn't just speculation, it was based on rigorous physics and observations that other natural explanations couldn't adequately address. The scientific establishment's reaction was swift and harsh, but Loeb stood firm in his assessment. The light sail theory that changes everything. The concept that Oumuamua could be an alien light sail isn't science fiction, it's cutting-edge physics that we're already developing here on Earth. Light sails work on a simple principle. Photons from stars carry momentum that can push extremely thin reflective surfaces. Just as wind pushes a ship's sail, starlight can propel a spacecraft equipped with a large, lightweight sail. The technology is so promising that organizations like Breakthrough Starshot are developing light sail probes to reach nearby star systems. Oumuamua's behavior perfectly matched what scientists would expect from a light sail. Its acceleration was consistent with solar radiation pressure acting on a thin, flat object. The lack of outgassing made sense because artificial objects wouldn't contain volatile materials that vaporize near the sun. Even its tumbling motion resembled how a damaged or derelict light sail might behave after millions of years in space. Maybe it was just alien craft technology that unintentionally lost itself, like space junk. Loeb suggested, making the theory seem less threatening and more plausible. The search for alien signals begins. The possibility that Oumuamua might be artificial technology triggered the most intensive search for alien signals in modern history. Breakthrough. Listen, the world's most comprehensive SETI program immediately turned the massive Green Bank telescope toward Oumuamua. If the object was indeed artificial, it might be transmitting signals, either intentionally or as electromagnetic leakage from its systems. The search was unprecedented in its scope and sensitivity. Over multiple observation sessions, the telescope scanned billions of radio frequencies, recording a staggering 90 terabytes of data, enough to fill 23 high-end computers. The observations covered different phases of Oumuamua's rotation, ensuring that any potential signals from different parts of the object would be detected. The sensitivity was remarkable. At Oumuamua's distance, the telescope could have detected a signal as weak as a cell phone transmission. If alien technology was aboard this mysterious visitor, we would have heard it. The results were both disappointing and reassuring. No artificial signals were detected from Oumuamua. The object remained silent as it tumbled through space, offering no direct evidence of alien technology. However, the absence of signals didn't disprove the artificial hypothesis. A derelict piece of technology wouldn't necessarily be transmitting. Why natural explanations fall short. The scientific community's resistance to Loeb's alien hypothesis led to, well, increasingly creative attempts to explain Oumuamua through natural processes, but each explanation just seemed to create new problems. One theory suggested that Oumuamua was a hydrogen iceberg, basically a chunk of solid hydrogen that would sublimate near the sun, causing the observed acceleration. But, solid hydrogen couldn't actually survive the millions of years needed for interstellar travel, and the object didn't show any of the expected hydrogen emissions. Another proposal claimed Oumuamua was a fragment of a disrupted comet, but this idea couldn't account for its extreme elongation or the lack of any cometary activity. Some scientists even suggested it was a dust bunny, meaning a loosely bound collection of particles, but an object like that would have been torn apart by tidal forces during its close approach to the sun. The most recent theory proposed that Oumuamua was made of nitrogen ice, kind of like Pluto's surface. While this could maybe explain some of the observations, it would require the object to have originated from a Pluto-like world in another star system, which is, honestly, itself a pretty extraordinary claim. So, each natural explanation required increasingly exotic conditions or materials, leading some scientists to start questioning whether the artificial hypothesis might actually be the simpler explanation. The implications of alien technology. If Oumuamua truly represents alien technology, the implications for humanity are, honestly, staggering, and fundamentally change our understanding of our place in the universe. The object's properties suggest it wasn't sent to spy on Earth or, make contact. Its trajectory showed no signs of course corrections toward our planet, and it was already leaving the solar system when we discovered it. This supports Loeb's theory that we encountered cosmic debris, the equivalent of finding a piece of alien trash just floating through space. Strangely enough, this scenario might actually be more significant than active alien contact. It suggests that technological civilizations are common enough that their artifacts regularly drift through the galaxy. If Oumuamua is artificial, it implies that advanced civilizations have been building interstellar technology for, millions of years, leaving a trail of debris in their wake. The discovery would also validate humanity's own technological trajectory. We're developing light sail technology for interstellar exploration, which suggests that this approach represents a natural evolutionary step for spacefaring civilizations. Oumuamua might be showing us our own future, a time when human-built light sails will traverse the galaxy, potentially becoming mysterious visitors to other star systems. The race against time and distance. One of the most frustrating aspects of the Oumuamua mystery was just how quickly the opportunity to study it disappeared, highlighting the challenges of investigating interstellar visitors. By the time scientists realized Oumuamua's true significance, it was already racing away from the sun at, honestly, incredible speed. The object was moving so fast that no existing spacecraft could catch up to it for a closer look. Even our most powerful rockets would have taken decades to reach Oumuamua, and by then it would be way too far away to study effectively. This time, pressure forced astronomers to make critical observations with ground-based telescopes while the object was still detectable. Every day that passed meant Oumuamua was getting fainter and harder to observe. The window for detailed study lasted only a few months before the object became too distant for meaningful analysis. The experience taught scientists some valuable lessons about preparing for future interstellar visitors. New detection systems are being developed to spot such objects earlier, giving researchers more time to study them. Space agencies are also considering rapid response missions that could be launched quickly to intercept future visitors before they escape our solar system. What Oumuamua means for the future. Oumuamua's brief visit has, without a doubt, fundamentally changed how we think about interstellar space and our search for extraterrestrial intelligence, regardless of whether it was natural or artificial. The object proved that interstellar visitors are detectable with current technology, opening a whole new field of astronomy. Scientists now know what to look for and have developed protocols for studying future visitors more effectively. The recent discovery of additional interstellar objects, including Comet 2I Borisov and the newly detected 3I Atlas, shows that Oumuamua wasn't a unique event. If Oumuamua was indeed artificial, it suggests that the galaxy might be filled with technological artifacts from ancient civilizations. This archaeology of the galaxy approach to SETI represents a new way of searching for evidence of alien intelligence, not through radio signals, but through physical artifacts drifting through space. The controversy surrounding Oumuamua has also highlighted the importance of keeping an open mind in science. Loeb's willingness to consider unconventional explanations, despite professional criticism, really demonstrates the value of following evidence wherever it leads. As we continue to develop our own interstellar technology, Oumuamua serves as a reminder that we might not be alone in this cosmic endeavor. From its mysterious acceleration to its impossible shape, Oumuamua challenged everything we thought we knew about our cosmic neighborhood. Whether it was a natural phenomenon or humanity's first encounter with alien technology, this interstellar visitor opened our eyes to possibilities we never imagined. As Joe Rogan and Avi Loeb showed us, sometimes the most extraordinary explanations deserve serious consideration. The truth about Oumuamua may remain a mystery, but its impact on science and our understanding of the universe will last forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic mysteries. On July 1, 2025, astronomers detected something extraordinary racing through our solar system at 152,000 miles per hour. This wasn't just another space rock, it was 3I/Atlas, a massive interstellar comet from beyond our solar system, potentially up to 20 kilometers wide and billions of years older than Earth itself. Unlike the mysterious Oumuamua that puzzled scientists in 2017, this visitor is showing clear signs of cometary activity with a glowing tail stretching thousands of miles. Today we explore humanity's third confirmed interstellar visitor and what it reveals about the cosmos. The discovery that shook astronomy. The story begins with what seemed like routine observations at the Atlas Telescope facility in Rio Hurtado, Chile. On July 1, 2025, the asteroid terrestrial impact last alert system detected a faint object moving against the backdrop of stars near the constellation Sagittarius. Initially designated A11PL3Z, this seemingly ordinary discovery would soon revolutionize our understanding of interstellar visitors. Within hours, follow-up observations revealed something extraordinary. The object wasn't following a normal elliptical orbit around our sun like asteroids and comets from our solar system. Instead, it was traveling on a hyperbolic trajectory with an orbital eccentricity of 6.15, the highest ever recorded for any object in our solar system. This mathematical signature could only mean one thing: the object originated from interstellar space. Amateur astronomer Sam Dean played a crucial role by discovering pre-discovery images of the object dating back to June 14, allowing scientists to calculate its precise trajectory. The Minor Planet Center received over 100 confirmed observations from telescopes worldwide within 24 hours, officially designating it 3I/Atlas, the third confirmed interstellar object ever detected, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. A colossal visitor from deep space. What makes 3I/Atlas truly remarkable is its sheer size and speed. Traveling at approximately 152,000 miles per hour relative to our sun, this interstellar giant could journey from Earth to the Moon in just over an hour. Early estimates suggest the comet's nucleus could be between 10 to 20 kilometers in diameter, making it potentially dozens of times larger than its predecessors. When Harvard astronomer Avi Loeb analyzed the brightness data, he discovered something striking. The object reflects an unusual amount of light for its distance, suggesting either a highly reflective surface or enormous size. If its surface is dark like most asteroids, 3I/Atlas would need to be roughly 24 kilometers across to produce such brightness, making it a true cosmic giant. Unlike the enigmatic Oumuamua, which showed no clear signs of cometary activity, 3I/Atlas immediately displayed classic comet behavior. Observations from the Nordic Optical Telescope by astronomers David Jewett and Jane Liu revealed a diffuse tail on July 2, while the Tade Twin Telescope Observatory recorded a tail stretching 25,000 kilometers. This active behavior confirms 3I/Atlas is indeed a comet, not an asteroid. A cosmic journey through our solar system. 3I/Atlas is currently positioned about 420 million miles from the Sun, roughly within Jupiter's orbit, racing inward on its one-way journey through our solar system. Its hyperbolic trajectory means it will never return. This is a single encounter that astronomers must maximize while the opportunity exists. The comet's path will bring it closest to Mars on October 2, 2025, passing within just 18 million miles of the red planet. Some researchers have proposed using NASA's Mars rovers to photograph the comet during this close approach, potentially providing unique surface-based images of an interstellar visitor. On October 29, 2025, 3I/Atlas will reach perihelion, its closest point to the Sun at approximately 130 million miles away, just inside Mars's orbit. At this point, it will be traveling at its maximum velocity of 68 kilometers per second. The comet will make its closest approach to Earth on December 19, 2025, though it will remain at a safe distance of 167 million miles. Throughout this journey, 3I/Atlas poses absolutely no threat to Earth. Its trajectory ensures it will pass safely through our solar system before continuing its eternal voyage into interstellar space. The oldest comet in the universe. So perhaps the most astounding aspect of 3I/Atlas is, honestly, just its incredible age. Research led by Matthew Hopkins at Oxford University suggests this interstellar visitor could be between 7.6 and 14 billion years old. potentially older than our entire solar system by more than 3 billion years. The key to understanding its ancient origins lies in its velocity and trajectory. With a hyperbolic excess velocity of 58 kilometers per second, 3I/Atlas is moving way faster than objects typically ejected from nearby star systems. This extreme speed suggests it originated from the Milky Way's thick disk, a region containing some of the galaxy's oldest stars, most of them over 10 billion years old. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains the significance. This is an object from a part of the galaxy we've never seen up close before. We think there's a 2/3 chance this comet is older than the solar system, and that it's been drifting through interstellar space ever since. If confirmed, 3I/Atlas would represent a pristine time capsule from the early universe, carrying materials that formed when the galaxy was young and star formation was just beginning. Global Telescope Network mobilizes. The discovery of 3I/Atlas has, well, triggered an unprecedented global observational campaign. Astronomers all around the world are pointing every available telescope at this rare visitor, knowing they've got only months before it disappears forever into the depths of space. The James Webb Space Telescope, with its massive 21.3-foot mirror and incredible infrared sensitivity, is perfectly positioned to study 3I/Atlas in detail. Webb can detect heat signatures and identify specific chemicals and minerals on the comet's surface, potentially revealing its composition and origin. The Hubble Space Telescope complements Webb's capabilities with its ultraviolet observations, providing a complete picture across different wavelengths of light. Ground-based observatories from Hawaii to Chile to South Africa are tracking the comet's movement, measuring its brightness changes, and analyzing the faint light it reflects. The European Space Agency is actively monitoring the object through multiple facilities, while the Instituto de Astrofísica de Canarias has contributed crucial observations using their Atlas-TD telescope and the Gran Telescopio Canarias. Radio telescopes like the Very Large Array in New Mexico are also listening for any unusual emissions as the comet interacts with the solar wind, making sure no potential signals are missed during this historic encounter. Comparing interstellar visitors. 3I/Atlas joins, an exclusive club of confirmed interstellar objects, each with unique characteristics that really challenge our understanding of the cosmos. The first visitor, 1I/Oumuamua, discovered in October 2017, remains the most mysterious. Its cigar-like or pancake flat shape and unexplained acceleration as it left our solar system sparked intense debate, with scientists like Avi Loeb even suggesting it might be artificial technology. The second visitor, 2I/Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, behaved more like a familiar comet with a visible tail and composition similar to comets in our solar system. Its nucleus was estimated at just 400 meters across, making it relatively small compared to 3I/Atlas. What sets 3I/Atlas apart is its combination of size, age, and clear cometary behavior. While Oumuamua showed no outgassing and Borisov was relatively young, 3I/Atlas displays active cometary features despite potentially being billions of years old. Its orbital eccentricity of 6.15 far exceeds both predecessors, indicating it's traveling much faster and likely originated from a more distant region of the galaxy. This progression from mysterious to familiar to ancient suggests interstellar objects are more diverse than we initially thought. Clues to galactic chemistry and life. While the composition of 3I/Atlas could, really revolutionize our understanding of how planets form throughout the galaxy. Early observations have detected a reddish coma surrounding the comet, which is actually pretty similar to what was seen in 2I/Borisov. This red coloration most likely comes from organic-rich dust containing these complex molecules called tholins, carbon-based compounds that scientists believe played a crucial role in the origin of life. If 3I/Atlas contains materials similar to comets in our own solar system, it would provide pretty powerful evidence that the building blocks of life are widespread throughout the galaxy. The presence of water ice, organic compounds, and complex chemistry would suggest that the ingredients for life aren't unique to Earth, but are actually common products of stellar evolution. On the other hand, if the comet's composition turns out to be entirely different from anything in our solar system, it would reveal the incredible diversity of conditions under which planetary systems can form. This could mean that 3I/Atlas formed around a star with different metallicity, or in a region of space with really unique chemical conditions. Either outcome would be scientifically revolutionary, either confirming the universality of life's ingredients or revealing new pathways for chemical evolution in the cosmos. Mysteries and unanswered questions. Mysteries and unanswered questions. Despite intensive observations, 3I/Atlas guards many secrets that continue to puzzle astronomers. One of the biggest mysteries is its exact size and rotation. While early estimates suggest a nucleus between 10 and 20 kilometers across, the active coma of gas and dust makes precise measurements challenging. Some observations suggest the comet might be tumbling chaotically rather than spinning smoothly, possibly indicating a violent past collision or gravitational encounter. The comet's unusual brightness remains another puzzle. Its high reflectivity could indicate a surface composition unlike anything in our solar system, or it might be experiencing an outburst that temporarily increases its brightness. Understanding this brightness is crucial for determining its true size and nature. As with previous interstellar visitors, some scientists are monitoring 3I/Atlas for any signs of non-gravitational acceleration, movement that can't be explained by gravity alone. While such acceleration is normal for comets due to outgassing, any unusual patterns could provide clues about the comet's internal structure or composition. The question of artificial origin, while highly unlikely, remains part of the scientific discussion. Avi Loeb has suggested using advanced telescopes to search for any signs of technology, though natural explanations are far more probable. Future missions and rapid response. Future missions and rapid response. The discovery of 3I/Atlas has accelerated discussions about rapid response missions to intercept future interstellar visitors. While this comet was discovered too late for any spacecraft to reach it, several space agencies are developing concepts for quick launch missions that could be deployed when the next interstellar object is detected. The European Space Agency's Comet Interceptor mission, scheduled for 2029, represents one approach to studying pristine comets. While originally designed for objects from our solar system, similar technology could be adapted for interstellar targets if sufficient warning time exists. The upcoming Vera C. Rubin Observatory will revolutionize interstellar object detection when it begins operations. Its enormous camera will photograph the entire visible sky every few nights, creating a movie of the cosmos that should detect multiple interstellar objects annually. Astronomers predict it might discover between 5 and 50 interstellar visitors during its 10-year legacy survey of space and time. This improved detection capability means future interstellar objects might be spotted months or even years before their closest approach, providing sufficient time to plan and launch intercept missions. Such missions could return samples from other star systems, bringing pieces of alien worlds directly to Earth for analysis. A new era of interstellar archaeology. A new era of interstellar archaeology. 3I/Atlas represents more than just another astronomical discovery. It marks the beginning of interstellar archaeology, the study of physical artifacts from other star systems. Each interstellar visitor carries information about distant worlds we may never visit, providing direct samples of materials that formed under completely different conditions than those in our solar system. The rapid succession of interstellar discoveries, 3 confirmed objects in less than a decade after centuries of seeing none, suggests these cosmic wanderers are far more common than previously thought. This frequency implies that planetary systems throughout the galaxy routinely eject material into interstellar space, creating a vast network of cosmic debris that connects star systems across the galaxy. As our detection capabilities improve and more interstellar objects are discovered, we'll begin to understand the diversity of planetary formation processes throughout the Milky Way. Each visitor provides a unique data point about stellar chemistry, planetary evolution, and the conditions that exist in different regions of our galaxy. 3I/Atlas, with its ancient age and pristine composition, offers a particularly valuable glimpse into the early universe, when the first generation of planets was forming around young stars billions of years ago. From its discovery in the Chilean desert to its journey through our solar system, 3I/Atlas has already transformed our understanding of interstellar visitors. This ancient comet, potentially older than our solar system itself, carries secrets from the early universe that could reshape our knowledge of planetary formation and the ingredients for life. As it continues its eternal voyage through the cosmos, 3I/Atlas reminds us that our solar system isn't isolated but part of a vast galactic community. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic discoveries. Somewhere in the frozen archives of Moscow lies evidence of humanity's most forgotten triumph. A successful Mars landing that happened decades before the world knew about it. Between 1960 and 1971, the Soviet Union launched a series of top-secret missions to Mars that were systematically erased from history books. While NASA celebrated its moon landings, the Soviets were quietly attempting something far more ambitious, reaching the red planet first. Mars 3 didn't just reach the Martian surface. It made the first successful soft landing in human history. Today, we're uncovering the declassified truth about the Soviet Mars program that the world was never meant to know about.
The shadow launches.
October 1960 marked humanity's first attempt to leave Earth's gravitational influence and reach another planet. Mars, 1960. A lifted off from Baikonur Cosmodrome aboard a modified R-7 ICBM, but within seconds the rocket veered off course and self-destructed. 4 days later, Mars 1960B suffered the same fate-reaching orbit but never escaping Earth's pull before burning up in the atmosphere. These weren't just technical failures, they were national embarrassments that the Soviet space program couldn't afford to acknowledge. Sergei Korolev, the chief designer of the Soviet space program, had promised Premier Khrushchev a Mars victory to match their successes with Sputnik and Yuri Gagarin. Instead, both missions were quietly reclassified as Cosmos satellites, a catch-all designation used to hide failed interplanetary attempts. Western intelligence agencies only learned about these missions decades later through declassified documents. The Soviet strategy was clear. If they couldn't succeed publicly, they would fail in complete secrecy. The engineers' work was a race against time, battling both the remoteness of space and the limitations of old technology. The successful restoration gave hope not only to the mission but also to
Mars 1, the lonely pioneer.
November 1962 brought the Soviet Union's first partial success with Mars 1, a probe that actually escaped Earth's gravity and began the long journey to the Red Planet. Launched during a narrow 26-month launch window, the spacecraft represented a technological leap forward, equipped with a magnetometer, cosmic dust detectors, and instruments designed to search for water vapor in the Martian atmosphere. For 124 million miles, Mars 1 transmitted data back to Earth, proving that interplanetary communication was possible. The spacecraft sent 61 successful transmissions before disaster struck on March 21, 1963. As Mars grew larger in the probe sensors, all contact was lost. Engineers at the Soviet Deep Space Network in Yevpatoria, Crimea waited desperately for signals, but Mars 1 had gone silent forever. The most likely cause was a leak in the attitude control gas tanks, which left the spacecraft spinning helplessly with its antenna pointing away from Earth. Despite the communication failure, Mars 1 proved the Soviets could reach interplanetary space, a crucial psychological victory that fueled their determination to continue.
The explosive disasters.
March 1969 witnessed one of the most spectacular failures in space exploration history. Mars, 1969. A sat atop a massive Proton K rocket at Baikonur, carrying the most advanced Mars probe ever built, a bus-sized spacecraft designed to orbit the planet and deploy a surface lander. The countdown proceeded normally until T+0 seconds, when the 2.4 million-pound thrust rocket erupted into a fireball visible for miles. The explosion shattered windows in nearby villages and sent burning debris across the Kazakh steppes. 5 days later, Mars 1969B met an equally violent end when the upper stage failed during separation, sending the multi-million-dollar payload tumbling back to Earth. These catastrophic failures represented more than technical setbacks. They were existential crises for the Soviet space program. Vasily Mishin, who had taken over from Korolev after his death in 1966, faced intense pressure from the Politburo to deliver results. The twin explosions cost the USSR 2 years of preparation and millions of rubles, but more importantly, they handed NASA a clear advantage in the race to Mars.
Zond 2's silent journey.
Zond 2's silent journey. So, late in 1964 marked another Soviet attempt with Zond 2, a spacecraft that really represented the cutting edge of interplanetary technology. This mission carried experimental plasma thrusters, revolutionary ion propulsion systems that honestly had never been tested in deep space, along with an infrared spectrometer designed to detect vegetation on Mars. For 6 months, Zond 2 flew silently through the void, its experimental systems functioning perfectly as it approached the red planet. The spacecraft's trajectory was nearly perfect, aiming for a close flyby that would provide detailed images of the Martian surface. Controllers at the Soviet Mission Control Center in Kaliningrad maintained regular contact until suddenly, all transmissions just ceased. The probe missed Mars by approximately 1,000 miles, agonizingly close to success. Post-mission analysis suggested either a power system failure or a thermal control malfunction had crippled the spacecraft. Zond 2 joined the growing cemetery of Soviet hardware drifting in interplanetary space, another ghost probe carrying humanity's dreams but unable to fulfill them. Each failure taught valuable lessons, but the Soviets were running out of time and patience.
The M69 catastrophe.
The M69 catastrophe. 1969 was supposed to be the year the Soviet Union finally conquered Mars. After years of failures, Soviet engineers had designed the M69 series, massive, sophisticated spacecraft that would not only orbit Mars but also deploy landers to study the surface. Mars 1969, A, and Mars 1969. B represented the pinnacle of Soviet space technology, each weighing several tons and packed with advanced instruments. The missions were so secret that even their existence was classified until decades later. When both missions exploded during launch within 5 days of each other, it created a crisis at the highest levels of Soviet leadership. Dmitry Ustinov, the defense minister overseeing space programs, personally intervened to prevent news of the disasters from reaching the public. The explosions were so violent they actually registered on seismic equipment, but official records listed them as routine Cosmos missions. These failures cost the Soviet Union more than money and prestige. They cost crucial time.
Mars 2, first impact.
November 27, 1971 became a historic date that, honestly, few people remember. Mars 2, the first component of the Soviet Union's most ambitious Mars mission, screamed through the Martian atmosphere at over 13,000 miles per hour. The lander was equipped with a parachute system, retro rockets, and even a small Prop-M rover designed to waddle across the surface on metal skis while tethered to the main lander. Everything that could go wrong did go wrong. The parachute system failed to deploy properly, the retro rockets never fired, and the lander slammed into the Martian surface with the force of a meteorite. There was no signal, no data transmission, just silence from the red planet. However, Mars 2 had achieved something unprecedented. It became the first human-made object to physically reach the surface of Mars. The impact occurred in the Hellas Basin, creating a small crater that remains there today, an unmarked grave for Soviet ambitions. While Western media focused on the failure, Soviet engineers quietly celebrated a grim milestone. They had touched another world, even if it meant destroying their spacecraft in the process.
Mars 3's miraculous landing.
Mars 3's miraculous landing on December 2, 1971, honestly rewrote the history of space exploration in just 14.5 seconds. Mars 3's lander descended through a massive planet-wide dust storm that had been raging for weeks, but somehow, everything worked perfectly. The parachute deployed, the retro rockets fired right on schedule, and the spacecraft made a controlled soft landing on the Martian surface. The first successful soft landing on another planet in human history. Controllers at the Deep Space Communication Center in Crimea erupted in celebration, as telemetry signals confirmed touchdown. For those precious seconds, humanity had a functioning robotic outpost on Mars, equipped with cameras, soil analysis equipment, and atmospheric sensors. The lander immediately began transmitting, sending back the first image ever captured from the surface of Mars. Then, as suddenly as it had begun working, Mars 3 fell silent forever. The transmission, it consisted mostly of gray static with some unclear features, but it represented humanity's first glimpse of Mars from ground level. The Prop-M rover was never deployed because the lander died too quickly. Somewhere in the Martian dust, that tiny robot still waits, a monument to Soviet engineering that survived the journey but just couldn't survive the destination.
The cover-up campaign.
Soviet space failures disappeared into a bureaucratic black hole of secrecy that lasted for decades. When Mars missions exploded during launch, they were immediately reclassified as Cosmos missions. generic designations that suggested routine Earth satellite deployments. Vladimir Chelomey, one of the chief designers, created an entire system for burying embarrassing failures behind false documentation. Launch manifests were altered, mission reports were classified, and even the engineers involved were sworn to secrecy under threat of imprisonment. The KGB monitored space program personnel to prevent leaks about failed missions. This wasn't just about hiding technical problems. It was about maintaining the Soviet Union's image as a space superpower. While NASA failures were broadcast on live television for the world to see, Soviet disasters vanished completely from public record. Western intelligence agencies sometimes detected mysterious launches through radar tracking, but without official confirmation, these missions remained ghosts in the historical record. The secrecy was so complete that many Soviet citizens never learned about their country's Mars program until after the USSR collapsed in 1991. This systematic cover-up meant that Soviet achievements, like Mars 3's successful landing, were also hidden from history.
The lost robot.
Buried somewhere in the Martian regolith lies Prop M, the Soviet Union's first Mars rover that never got to rove. This lunchbox-sized robot was designed to crawl away from the Mars 3 lander using metal skis, dragging a tether cable behind it to maintain communication. The rover carried a penetrometer to test soil density and 2 contact sensors to detect obstacles. Prop M was designed to operate for months, slowly mapping the immediate landing area and sending back detailed surface analysis. The rover represented groundbreaking engineering. It had no wheels because Soviet engineers worried they would clog with Martian dust. Instead, the robot was designed to slide forward on twin skis while explosive bolts periodically advanced the device in small hops. When Mars 3 died after 14.5 seconds, Prop M never received the deployment signal. The rover remains locked inside the lander, perfectly preserved by Mars's thin atmosphere and extreme cold. NASA's orbital reconnaissance has never located the Mars 3 landing site, meaning Prop M could remain lost forever. This tiny robot represents humanity's first attempt at mobile Mars exploration, a precursor to Sojourner, Spirit, Opportunity, and Perseverance that came decades later.
Hidden history revealed.
The full scope of Soviet Mars ambitions only became clear after 1991, when classified archives began opening to researchers. Documents revealed at least 18 secret Mars missions between 1960 and 1973, with many more attempts that remain classified. The Mars 3 success was deliberately downplayed even in internal Soviet documents because the 14.5-second transmission time seemed embarrassing compared to ongoing Apollo achievements. Roald Sagdiv, former director of the Soviet Space Research Institute, later admitted that political pressure forced engineers to attempt impossible deadlines with inadequate testing. Each mission failure cost millions of rubles and years of preparation, but the secrecy meant these lessons couldn't be shared with the international scientific community. The Soviet Mars program represented one of history's most ambitious scientific endeavors, combining cutting-edge technology with Cold War desperation. Mars 3's achievement, the first successful soft landing on Mars, remained largely unknown until decades after it happened. Today, as NASA and SpaceX plan human missions to Mars, they're building on foundations laid by Soviet engineers who dared to reach for another world in complete secrecy. The Red Planet conquered the Soviets, but not before they conquered it first. The Soviet Union reached Mars first, landed successfully, and sent back humanity's first surface image. But almost nobody knew about it. Mars 3's 14.5-second transmission represents one of history's most underappreciated achievements, buried by Cold War secrecy and overshadowed by moon landings. These declassified missions prove that space exploration's greatest victories sometimes happen in complete silence. The race to Mars wasn't won by the loudest publicity, it was won by engineers who dared to fail in secret until they finally succeeded. Subscribe to Stellar Tech for more hidden space history that rewrites everything you thought you knew about the cosmos.